So today we do a linked list, and um, obviously before anything else we do establish every single item per se. So obvious, talk about spell, right? We talk about linked list. Obvious, you do actually argue that you want to fight against linked list, you use brute force. So conditioned before and then after. So I just feel that when so let's play it out. So the first thing, first item that the requirement that they establish straight up is that n equals 2. So where 2 is saying that from they want to remove the second element per se. So therefore this is 1, this is 2. So eventually they want to actually remove this. And what they want to do is actually design something around this mechanism, and that you are able to actually remove the second node. So that's what they try to do. So at the they talk about, like, very intuitively speaking, on the brute force way on how they actually gonna do it. So first thing they started out saying, let's use 2 pointer per se. So you have a L and then you have R, and notice their gap is 2 gaps away, right? And then so they start on marching forward. So L comes to here, R comes to here, L comes to here, wait, L comes to here, R comes to here. So notice they're moving at the same speed. L comes to here, R comes to here. Done. We found this second one, because usually the ending point is usually after the last node, which is over here, and that kind of like indicate that that's the end. There's no more. That's why you strategically arrange 2 gaps in between. So notice they are constantly on 2 gaps away. So once you reach the sort of like ends right node, you reach the null node, that means 2 gaps away, it will be the node that you want. Fine. So the thing is this, that you got to be on the actual node for you to actually remove. So you need this one. That's why they introduce a dummy node per se. So the dummy nodes are introduced right over here. And what it does is that you establish your L to be here instead, so that eventually you will be able to land the one that is before it, so that you can actually remove the next nodes, because that's how you move the next nodes. You put this action verb, put the action verb over to the node that you want to skip, and that's how you actually remove these nodes. So that's how they actually do it, just producing this dummy node per se before, one node before. So it was set out to actually eventually land over here, obvious that all these were cancelled out per se. And yep, there you have it. That's how they actually played out. I feel like the rule from the very get-go, he already say that he already established that the rulebook is already saying that okay, we need the n equals to 2, whereby 2 is like the gap. They want to actually remove this this n value per se. That's the rulebook. And then that was why we sort of like start establishing a dummy node per se. And I just feel that our dummy node now has become a sort of like a sub spell, I would say. It's just like there to kind of like the main purpose is to actually have like a maneuver your node better. So I would say it's like better moving around the map. It helps to improve that. I think that's what dummy node is for. And the other thing is that straight up during the Leetcode question rulebook, it straight away established that it says that okay, we're working on linked list, and obvious, you straight away establish your spell to be linked list per se. And what's so nice about linked list is that they want to remove, right, and that actually linked list is very well known for its manipulation around the map per se, and that you can actually, you know, like decorate this LNR pointer. As long as you know where you're pointing at, you can sort of like remove no matter how many elements inside your node per se. So it has that versatility, I would say. So I'll give you a V record for that. That is very versatile in how it actually am able to remove data per se. That's very great. So yeah, I just feel that this question per se is just trying to really highlight the utility of linked lists, that you can actually big O of you are actually be able to actually effectively remove n element if you want to in the linked list. It's just trying to actually introduce you to that. The other thing is that when we talk about say brute force, I just feel like at the very start, as we were explaining, that was like the brute force way, saying that okay, we set out a 2-pointer, go towards the end, and then we realize that oh, damn it, if my L is over here, yeah sure, I know that this is the node that I want to remove, but usually when you want to remove your node, like say this is the node that you want to actually remove, you actually have to be on the node before it to actually remove this data per se. So it's just highlighting one of the feature that you got to do. I think first and foremost, what it does over here is that for a linked list, it has a property of action verb per se. and your action verb is sort of like limited by being on the actual node. So if say that I want to action verb this 3 to 5, I need to be on this node, I can't be at 4. So I need to actually make it towards here. So we started creating the dummy node, eventually coming to here, and then we action verb this towards the 5, and that's how we actually remove the node. Like in actual reality, we want to remove 4, but you can't have your pointer to be at over here. You have to be on the before to activate your action verb, because on this node you can't action verb. You can't be doing this action verb over here, unless you're telling me that you want to remove 5 per se. Sure, but if you want to remove this node over here, you got to actually be before it and actually action verb over. So that's why the limitation of like the action verb per se. So really well done. I think brute force always creates a lot of like inspiration in how we actually discuss about this topic. So I'm really glad for this one. And so yeah, that's it for this one. Have fun. Everything comes to an end.